Okay, shifting to section 4.3. We have been talking about introduction to trig. We've been defining things like reference angle and coterminal angle. We're going to revisit those a little bit today. We looked in section 2 at finding the trig functions for some of our special angles, right? The 30, 60, 90 stuff, 45, 45, 90. Okay, we're going to extend that today. It's called the circular functions because eventually we're going to make it all the way around our circle. Okay, we call it the unit circle. You probably walked past a picture of it in the hallway on your way to class. Yes, big unit circle in the hall? Okay. So we're focusing on taking an angle that maybe was in quadrant 1, right, an acute angle, and we're going to look at can we find the trig functions of angles that land in other quadrants. Okay. So find trigonometric functions of any angle, find trigonometric functions of real numbers, describe the period of those trig functions, and then we're going to start working on the unit circle. We won't get through all of that today, but we should hit the first couple. All right, so quick review. Go ahead with your partners. I want you to label the initial side, the vertex, and the terminal side for this picture. Okay, so for our first picture, we have angle alpha, also labeled angle B. So down here for your vertex, we have the point B. Yes? How would we label the initial side? How did we do that with our... Okay, so it is BC, but it's a ray, right? It has an endpoint and then an arrow. So we did this symbol. Yes? And then our terminal side would be BA. Okay, so you're going to see some of that notation, just how we label angles and triangles as we go through here. Our first few slides have a lot of review material from the first part of this chapter, so we're going to go through it kind of quickly. The measure of an angle is the number that describes the amount of rotation from your initial side to your terminal side. Okay. What two types of systems do we have for measuring angles? Degrees and radians. Okay. Positive rotations are which direction? Counterclockwise. And then negative rotations are clockwise. Standard position is when we place the initial side on the positive x-axis, and then we rotate our terminal side around. Okay? So you have two pictures here, one with a positive rotation indicated by this arrow, and one with a negative rotation indicated by going clockwise. So how could two different angles have the same initial and terminal side? We simply move in different directions, either a positive or a negative direction. Okay, so clockwise rotation and counterclockwise rotation. Would your angle measures be the same? Would your angle measures be the same? Okay, so if we were at exactly 180 degrees, but one would be a positive 180, one would be a negative 180, so there's still technically two different measurements. Okay. What did we call those? Coterminal angles, yep. So you land in the same spot. Your terminal side is in the same spot. You're just going to it in different directions. Okay. So how did we come up with coterminal angles if we were measuring them in degrees? Okay. So plus or minus. Now I'm going to say 360 n. Okay. Where n is an integer. Remember that notation? N is an element of the integers. Because we can add and subtract 360 a whole bunch of times, right? We're still going to land and get a coterminal angle. What about if it's in radians? Okay, so now we can add or subtract 2 pi, again, n times, right? Multiple times. What if my angle was in thirds? Okay, so like I had an initial angle of 2 pi over 3. Then what would I think of adding to get a coterminal one? 6 pi over 3, right? We just convert that 2 into, so it has a common denominator. Does that make sense? Okay, so we're adding and subtracting 2 pi, but sometimes we have to think of it as a fraction. All right. So I have 3 examples here. I want you to draw and determine the measurement for a positive and a negative coterminal angle to the one you're given. I'm going to pause the recording, give you a few minutes to do that, and then we'll check. All right, so I've drawn the original, the given angle. It says they want us to find a positive and a negative coterminal angle. So if I have 30 degrees to start with, and I add 360, I get what? 390. So that would be my positive coterminal angle. It just means that I spin around an extra rotation before I get there. Yes? Okay. For the negative one, if I take 30 degrees and subtract 360, I'm at what? Okay, negative 330 degrees, which means I would be going in a negative direction. So that angle would go all the way to here. Yes? So either draw separate axes to show the different angles or use different colors like I did. Okay, but you need to be very clear which one's which. All right, second example. I want a positive coterminal. So negative 150. If I add 360, it puts me in the positive section. By how much? 360 minus 150. Okay, so a positive 210 degrees would go this direction. Yes? Okay, for the negative one, negative 150 minus 360 puts me at negative, what? 510? Okay, so going in a negative direction, I have to spin an extra time. So I'm going from here all the way around once, and then again to land at my terminal side. All right, the last one is in radians. So we are going to think in terms of adding and subtracting 2 pi, but since it is divided into thirds, I'm going to think of 2 pi as being 6/3. Okay, so I'm going to just add and subtract 6/3. So for my positive rotation, I have 2/3 pi. I'm going to add 6/3 pi, which puts me at 8/3 pi. So a complete rotation plus the extra 2/3. Okay, for the negative one, I have 2/3 pi. I'm going to subtract 6/3 pi, which puts me in the whole 4/3 pi. So then I have to go in a negative direction. Here's 3/3 plus an extra third puts me at negative 4/3. Okay, so quick review of our coterminal angles. So we started out, when we talked about our trig functions in section 4.2, with just being in quadrant 1, thinking of an acute right triangle, right? And our angles that we were working with were always smaller than 90 degrees, so they would have landed in quadrant 1. We want to be able to extend that. So quick review, quadrant 1 is upper right corner, and then we go in our positive direction, right? So counterclockwise to quadrant 2, quadrant 3, quadrant 4. Take a minute and think about your x and y coordinates in each quadrant. Identify if x is positive or negative and if y is positive or negative. In other words, in quadrant 1, x is positive and y is positive. Yes? What happens when we go to quadrant 2? What changes it? If I want to point over here in quadrant 2, what can you tell me about the coordinates? Okay, x is negative, but y is still positive. Okay, if we go to quadrant 3, both negative, and quadrant 4, positive x, but negative y. Okay, that's going to come into play when we start defining how to find these trig functions in other quadrants. So the first thing it says, we want to let P be a point x, y. We're going to start out in quadrant 1 and let R be the distance from the point P to the origin. All right, so let's sketch a picture. All right, let's find a point here in quadrant 1. We'll label that P. Okay. If we make a triangle out of that, and we say it has coordinates x, y, to create this triangle and have our angle be in standard position, so over here, then x is positive and y is positive. Okay, so I'm going to go x spaces to the right, y spaces up. They said let R be the distance from P to the origin. So that's the hypotenuse of my triangle. Now it says use the acute angle definition for the sine function to prove that sine of theta would be y over r. How did we define it in terms of opposite, adjacent, hypotenuse, all of that? Sine was which sides? Opposite over hypotenuse? Okay, so based on my picture, which side would be opposite? The y? And hypotenuse would be r. So we have proved that the sine of theta can be defined as y over r instead of opposite over hypotenuse. Okay, another type of definition. How would I express cosine? Which sides would get used for cosine? Okay, adjacent and hypotenuse, which would make this, in my picture, x over r. Tangent uses which sides? Okay, opposite over adjacent. And again, in my picture, that would be y over x. Okay. You are going to want to know that new definition using x, y, and r instead of relying on opposite, adjacent, hypotenuse all the time. Okay? As we move to our unit circle in the next few days here, everything's going to be in terms of x and y's. All right? So we really have to start thinking of that. Cosine uses x. Sine uses y. And if you think about it, x comes before y in the alphabet. Yes? And cosine comes before sine in the alphabet. So it's alphabetical. And that expression is going to make more sense as we go through the next few days. Okay? But start getting in your mind. Cosine is x, sine is y. Okay? How could we define the other three trig functions? If we've already defined our main three, the others are just reciprocals. So which one is the reciprocal of sine? Good. Cosecant, then reciprocal of sine would be r over y. Secant is the reciprocal of which one? So r over x. And cotangent is the reciprocal of tangent, so x over y. Okay? Example 2, it says let theta be an acute angle in standard position. So which quadrant would it be in? An acute angle in standard position. We're in quadrant 1 still, okay? Whose terminal side contains the point 5, 3. So the very first thing I want you to do is sketch it. All right, so we have a point here at 5, 3, and we know that's on the terminal side of my angle. So I'm going to draw a ray through that point, and I'm going to create a triangle out of this. And we talked the other day, initial side we're going to have on the positive x-axis here, right? And I want to make a triangle out of it, so I'm going to look at it like this. Okay? And so the angle that they're working with here, theta, would be in this position. All right. If we know that this point is 5, 3, that means we have moved 5 spaces to the right. So this horizontal piece of my triangle would have a length of 5, and the vertical piece would have a length of 3. Yes? How can we find the hypotenuse, the r in our definition? Okay, so 3 squared plus 5 squared equals r squared. We use an r because it's going to reference the radius of our unit circle. We'll come back to that in a couple days. 3 squared is 9. 5 squared is 25. Adding them, we get 34. So r would be the square root of 34. Do I need the plus minus in front of that? Why not? Okay. Doesn't matter which quadrant we're in. R is measured a distance, right? So it's always going to be that positive value. Okay. That's not what I wanted to do. Okay. So we have the square root of 34 for that piece. It says find all 6 trig functions. We know our x, we know our y, and now we know r. Okay? So this is x, this is y, this is r. So we want all 6 trig functions. I usually pair them up with the trig function and its reciprocal. Makes it easier. Okay, so the sine of theta. Sine we said was y over r. So 3 over root 34. Rationalize, that would be what? Good. 3 square roots of 34 over 34. Now, its reciprocal, we want to go back to the unrationalized version, because when we flip that over, now we have root 34 over just a plain 3. Okay? So it's easier to do the reciprocal before you've rationalized it. Okay, cosine. Cosine uses x over r. So we have 5 over 34, square rooted. Rationalized, 5 root 34 over 34. Reciprocal would be secant, so root 34 over 5. All right, and last one. Tangent uses which sides? Opposite over adjacent, which in our picture is labeled y over x. Okay? So y over x would be 3 over 5. Nothing to rationalize there. Cotangent would be 5 over 3. All right. We use the same definitions for x, y, and r whether or not x and y are positive or negative. Meaning, we can move to other quadrants. We've talked about that x's and y's change signs depending on what quadrant we're in. But we can still use those same values. Okay? So, why is r always going to be positive in this scenario? Okay. So, r is defined as the distance from the origin to that point P on the terminal side. So r will always be positive, even though x and y are going to alternate depending on what quadrant we land in. All right, example 3. It says let theta be any angle in standard position whose terminal side contains the point negative 5, 3. And now we want to find all 6 trig functions. So sketch a picture, draw your terminal side so it goes through the point negative 5, 3. All right, before you go any further, I want to check your picture. We want the point to be negative 5, 3, so we're going to negative 5 in our x direction and positive 3 in our y direction. We good? But keep in mind that the triangle you draw needs to have a perpendicular down to the x-axis. Okay? So the triangle that we're going to look at is going to be this one. Okay? Now, our original angle from standard position would go from here to here, correct? The triangle where I write theta there, theta would be called what in terms of that original angle? Reference angle. Remember when we find reference angle, we go to the closest x-axis? And one of the things you need to know about is that your trig functions for angles and their reference angles are going to be the same, with the exception that you might have to adjust the sign depending on which quadrant you're landing in. Okay? So we can find the 6 trig functions of theta, the original standard position angle, by looking at our reference angle. But when we label our sides of our triangle, even though technically we are measuring a distance, how many spaces we move, we have to indicate what direction we're moving. So for this particular triangle, I'm going to label the x-axis here as a negative 5 because I went to the left 5 spaces, and then I'm going to go up positive 3. Okay? So my x value has to be negative 5, my y value has to be 3. What's my r value going to be? Same as our last picture, right? Square root of 34? Okay. So how will our answers change compared to what we had in example 2? Which ones? Some functions will be negative. Which ones? Any that use an x. Which trig functions use an x? Cosine and tangent, secant, cotangent, right? We have to adjust those. Okay, so let's just go through them quick. Sine of theta, cosecant of theta. What do we get for sine? What do we get for sine? Opposite over hypotenuse, y over r. Square root of 3 over root 34. Rationalized, we'd have 3 root 34 over 34. Okay? Cosecant is the reciprocal, so root 34 over 3. Okay? Those are still positive. But cosine now becomes what? All right, negative 5 root 34 over 34. So you rationalized it already? That's fine. Secant, though, go back before you rationalized. And it's going to be negative root 34 over 5. Does it matter if I put the negative sign right out front or if I leave it with the 5 on the bottom? No, doesn't matter. All right, tangent. Tangent we said was y over x. So 3 over negative 5. And then cotangent, it's going to be negative 5 over 3. All right. It says, note there is an infinite number of coterminal angles that would have those same 6 trig functions. So if I spin around an extra rotation and still land in the same terminal side, right, all of these trig functions answers are going to be the same. That's why we can use that reference angle, okay, to find them all. Because it doesn't really matter how many times we spin around. All right, so there's your formal definition of all the things we've been talking about with our whole x, y, and r values. And our next example changes things up a little bit. It says, what happens if we're not given the point? If we're not told the xy coordinates of where that terminal side is? If you have one of your known angles, 30, 60, 90, 45, 45, 90, right? One of our known special angles, you can figure it out because we know how to draw the triangles and how to label those sides. If it's something else, then we'd have to go to our calculator. Okay? So, 315. Sketch where that angle would get me. It's a positive 315. Which quadrant am I going to land in? Quadrant 4? Okay. How far am I from being a full rotation? 45 degrees? So we are going to land, if this is my initial side, we're going to land over here. Correct? Okay. Remember, your vertical piece always goes to attach to the x-axis. So the triangle we're going to look at is going to be this one. Okay? My reference angle would be right here. I labeled it theta. And my trig functions for theta are going to be the same as the trig functions for 315. Correct? But we said where I labeled theta, that's a 45-degree angle. So how would I label the sides? What are the sides of a triangle that's 45, 45, 90? 1, 1, root 2. Now think about the quadrant we're in. So what would this point be if my sides are 1, 1, and root 2? Are these both positive 1s, the way I've drawn it? No. To get to this point down here, I had to go positive 1 for x, but negative 1 for y. Okay. So I'm going to give you some time. I'm going to pause the recording. Go ahead and list your 6 trig functions for 315. All right, let's check your answers. For sine of 315 degrees, and notice I included the number 315 because that's technically the angle they're asking us to find. We're just using the reference angle to help us. Okay, so the sine of 315 degrees should be negative root 2 over 2. Cosecant would be negative root 2. Cosine of 315 degrees should be positive root 2 over 2. And secant should be root 2. And then tangent and cotangent both end up being negative 1. You good with that? All right. So just kind of some basic steps. You're going to draw your angle in standard position. Make sure your terminal side is landing in the correct quadrant. You're going to label that point P on your terminal side and figure out the 2 legs of your triangle. Okay? You want to draw a perpendicular segment from your point down or up to the x-axis and use that reference triangle. If it's one of our special triangles, you can label your sides, 1, 1 root 2 or 1 root 3, 2. And then if it's not, we'll have to use our calculator. Okay? We can use our triangle to help us find the coordinates of point P and then find our 6 trig functions. So this time we're not finding all 6 trig functions. I just gave you a specific one to do. Okay, so the first step is draw your angle and then draw your reference triangle. So for 210, if it's negative, what quadrant are we going to land in? Going in a negative direction, right? So clockwise from here, this would be 180. We have to go how much more? An extra 30 degrees? Okay, so in terms of my reference triangle, my reference angle here is 30 degrees. Yes? Okay, how do we label the sides in a 30, 60, 90 triangle? What's the side opposite 30? A 1, hypotenuse is 2, and the longer leg is root 3. But think about the quadrant we're in. Would any of those legs have a negative measurement? The negative root 3? Okay. And now we just have to figure out which sides do we use for sine. Sine is opposite over hypotenuse, or y over r. So 1 over 2. That's the one I told you guys to memorize. Remember that? Sine of 30 is 1/2. Okay. Well, the next two are in radians. Fun stuff. Everybody's favorite. We have to think in terms of thirds. Are we going positive or negative? Positive, so this time counterclockwise. 5/3. What quadrant are we going to land in? If this is pi, or 3/3 pi, all the way around gets me to 6/3 pi. So I'm a little shy of that. I'm 1/3 shy of that. All right, so here's my initial. I'm going to go to here. My reference triangle is that. How big is this angle here, my reference angle? Give me in radians. I gave you the angle in radians. You're going to talk to me in radians. Pi over 3, right? That's the portion that I haven't gone all the way to a full 2 pi. So my reference angle is pi over 3. Okay? And pi over 3 is 60 degrees. So when we think about drawing our sides and labeling them, right, this would be the bigger angle. So the side opposite that pi over 3 angle would have to be my root 3 piece, which makes this side a 1, and it makes my hypotenuse a 2. Are any of those negative? All right, my y-coordinate here, negative root 3. And we want the tangent. Tangent uses which ones? Opposite over adjacent, or y over x. Tangent is sine over cosine. Sine is y, cosine is x. All right, so y over x puts us at negative root 3 over 1. Or just negative root 3. All right, last one. We are going in a negative direction. We're thinking in terms of fourths. Okay, so if I'm starting here at 0, this would be negative 4/4 pi. Yes? All the way back around would be negative 8/4 pi. So I'm starting here, I'm going that direction. I need to go to -3/4. Which quadrant do I land in? Okay. Agree? That's -3/4 of the way, which means my reference angle is what? This angle here is pi/4, and reference angle is always a positive angle. All right, we don't list it as negative. So this is pi/4. How about the sides? If we have pi/4, what degree is that? 45, so we have 45, 45, 90 triangle. Okay, so our legs are 1s and our hypotenuse is √2. Are any of those negative? Both of the legs, yes. Okay, so if we want secant, secant is the reciprocal of which one? Cosine. Cosine is defined to be x/r, which means secant is going to be r/x. So the radius is √2, and the leg is -1. So our secant would be -√2. Okay? Tomorrow we will start with what happens if our terminal side lands on an axis. Okay? All right, your assignment. Day 1.